Hi everyone. My name is Akhil Arora, and I'm an assistant professor at Aarhus University, where I lead the Clan for AI Research on Language and Networks, or CLAN for short. I'm also an external collaborator of Wikimedia Research. Today, I'll talk to you about a practical and challenging problem faced by Wikipedia editors, which we term as entity insertion, and we'll also present a model to support editors in solving this challenging task. This is joint work with Tomasz, Devjit, and Bob from EPFL, and Martin from the Wikimedia Foundation. So before we dive deep, let's try to understand what is this problem, right? So basically, let's try to contrast it with a well-known problem in natural language processing called entity linking, where the goal is really to look into different spans of text and try to ground these spans into concepts from a knowledge base like such as Wikidata or Wikipedia articles. And let's again look at this example where the goal was to try to ground this term Margaret Peggy Woolley to a concept, right? And the way to do this was to really link it to Margaret Woolley's article on Wikipedia, right? And in this case, the problem is simpler because here the only task is to identify a suitable mention that is existent from the text where which can be made blue, right? On the other hand, the entity insertion problem is what is being shown here is with this red colored box and red font, where we look at the version of the page where which existed before even the concept was inserted. And the goal really is for an editor to now identify, because there is no text that exists yet, but identify a suitable position where she can insert the entity along with its mention or anchor that can be made blue for inserting this. As you can see with this specific example here, the mention private school was not even existent in the version of this page before. The private school entity was inserted, so the editor actually had to insert both the text and the entity. So this problem is not even just, let's say, interesting, but it's also quite challenging, right? Because we looked at real scenarios from Wikipedia by looking at consecutive pages, and we found that in 65 to 70% of the cases when new concepts were inserted, so there was no text that was existent for the editors to just make the link or add the concept by making a piece of text blue. The editors actually had to insert a new concept. And it's not even that, right? Many pages in Wikipedia are quite long, right? And doing this, actually solving this problem for articles that are small is relatively easier. But what about pages that have thousands or even 5,000 sentences, right? Which is represented by this plot, x-axis on this plot, and which in these cases, the cognitive load on the editor is too high for them to solve this problem in a realistic way. So before we actually could train a model, we actually then looked into the actual entity insertions in Wikipedia to create a benchmark data set, of course, not with which we can train our model, but also with which we can evaluate in a more realistic way, right? For that, what we did is we looked into links that were inserted in Wikipedia in 2 consecutive months. And then we actually went ahead to look in a more detailed way into the revision history of these pages where a new link was added. And then we identified 2 successive versions of the same article in which the link was not present in the version before, but in the following version, a new link was added. With this, what we could identify is the exact changes that were done to actually introduce this new link. And as you can see from this example, we were able to really identify between these 2 consecutive versions of a page that to insert the link private school or to insert the entity private school, the editor also had to add a piece of text. With this, we actually created a massively multilingual data set of entities and their surrounding context in 105 languages on Wikipedia. And using this, we actually trained a model, right? And the model is actually a fine-tuned XLM Roberta model, but it's much more than that, right? Because it's not just a simple fine-tuning exercise. We actually employed novel data augmentation strategies to mimic real-world scenarios for entity insertion. As you can see from this example, what we did was basically we tried to simulate the same scenario. For instance, let's say a particular sentence was not present at the time of insertion, or a span of text was not present, or just the mention was not present, right? So we did this kind of augmentations, or let's say corruptions at the time of training the model, so that the model only sees a specific portion of the text with this aspect removed. That's why they're called RM here. And with this, we were actually able to mimic the real world scenarios and train the model to actually perform this task in a realistic way. There are many other clever modifications and tricks that we employed in this training pipeline. If you're interested, feel free to talk to me during the workshop or read our paper. I'll share the URL at the end of the presentation. But enough of that. Just wanted to mention that with this model, we were actually able to achieve very, very strong results. We were actually able to see that our model significantly outperforms all baselines in the context of multilingual entity insertion. And not just that, we are also able to actually have our model outperform all the baselines, even in English. But more promisingly, we saw that we were able to outperform all the state-of-the-art large language model-based retrievers or rankers that are popular for these tasks in the domain. And we also actually employed this model in a zero-shot setup where we found that even our zero-shot model outperforms all the language-specific models that were trained for that specific language for this task, which is an interesting and a very clever finding because then this allows us to actually deploy this tool live on Wikipedia. Okay, so I'd like to now wrap up that today I talked to you about a challenging and practical problem faced by Wikipedia editors called entity insertion. We introduced a novel and challenging massively multilingual dataset to study this problem. And this can also be seen as an interesting benchmark for many other NLP tasks. And we found that editors actually need support to insert these entities, for which we devised a novel model. And we're currently working on a tool that will help Wikipedia editors on this task. As a broader implication, this work provides a fresh perspective on knowledge gaps and the costs associated with maintaining high-quality Wikipedia articles. With that, I would like to thank you. And this is my online digital footprint. These are some resources for the GitHub, for the Zenodo of this data set, and also a link to our preprint.